In today's video, I am going to discuss about permanent casting. There are four main types of permanent mold casting: gravity, slash, low pressure, and vacuum. First to discuss is the gravity process. The gravity process begins by reheating the mold to 150 to 200 degrees Celsius to ease the flow and reduce thermal damage to the casting. The mold cavity is then coated with refractory material or a mold wash, which prevents the casting from sticking to the mold and prolongs the mold life. Any sand or metal cores are then installed in the mold is clamp shut. Molten metal is then poured into the mold. Soon after solidification, the mold is opened and the casting removed to reduce chances of hot tears. The process then started all over again, but preheating is not required because the heat from the previous casting is adequate and the refractory coating should last several castings. Because this process is actually carried out on large production run workpieces, automated equipment is used to coat the mold, pour the metal, and remove the casting. Next to discuss is slash. Slash casting is a variant of permanent mold casting to create hollow casting or hollow cast. In the process, the material is poured into the mold and allowed to cool until a shell of material forms in the mold. The remaining liquid is then poured out to leave a hollow shell. The resulting casting has good surface detail but the wall thickness can vary. The process is usually used to cast ornament products such as candlesticks, lamp bases, and stationery from low melting point materials. A similar technique is used to make hollow chocolate figures for Easter and Christmas. The method was developed by William Brittain in 1893 for the production of lead toy soldiers. Next is the low pressure. Low pressure permanent mold casting uses a gas at low pressure, usually between 3 and 15 psi, to push the molten metal into the mold cavity. The pressure is applied to the top of the pool of liquid, which forces the molten metal up refractory pouring tube and finally into the bottom of the mold. The pouring tube extends to the bottom of the ladle so that the material being pushed into the mold is exceptionally clean. The vast majority of LPPM casting are from aluminum and magnesium, but some are copper alloys. Advantages include very little turbulence when filling the mold because of the constant pressure, which minimizes gas porosity and dross formation. Mechanical properties are about 50% better than gravity permanent mold castings. The disadvantage is that cycle times are longer than gravity permanent mold castings. Next is the vacuum. Vacuum permanent mold casting retains all of the advantages of LPPM casting, plus the dissolved gases in the molten metal are minimized and molten metal cleanliness is even better. The process can handle thin walled profiles and gives an excellent surface finish. Mechanical properties are usually 10 to 15% better than gravity permanent mold castings. The process is limited in weight to 0.2 to 5 kilograms. Advantages and disadvantages of the vacuum casting. The main advantages are the reusable mold, good surface finish, good image accuracy, and high production rates. On the other hand, there are three main disadvantages of the vacuum: high tolling cost, limited to low melting point metals, and short mold life. That's all for this video. Thank you for listening.